What kind of skill set is achieved after you solved over 1,000 problems on Leetcode? Is it true that after you solve 1,000 problems on Leetcode, you are absolutely cracked? Right? That is to say, after you solve 1,000 problems, there's nothing that you can't conquer. You've seen it all. You've seen dynamic programming, linked lists, circular linked lists, singly linked lists, doubly linked lists, heaps, priority queues, depth first search, breadth first search, uniform cost search, union find, quick union find, weighted quick union. You've seen it all, right? Can you solve any problem? No, you can't, right? Because the sad reality is that all of us have a certain amount of intellect, right? There's this IQ score bell curve, and you're somewhere on that bell curve. Now, what solving 1,000 problems will provide you with is the capacity to move yourself a standard deviation above, or maybe a standard deviation and a half, something like that, above where you're actually at, right? So it pushes you significantly, but it's not going to make you an absolute 10x engineer who will get into Google and Facebook and put your favorite company's name here, right? It's not gonna do that for you, but it will put you in a position where you can push yourself to the next level. Okay? And that's all that is really necessary for an average person like myself, right? Because, I've kind of, guesstimating here, self-assessment, that from doing over 1,000 problems, I'm in a position now where if you give me an easy problem, I can solve it probably 95% of the time, right? If you give me a medium problem, I can solve it probably 70% of the time. And if you give me a hard problem, I can solve it probably 35, we'll say 30% of the time. Okay, so what's the probability that I'll get a roll with that kind of metric? So let's just imagine I'm in a situation where, I solve 3 Leetcode problems, right? So I solve one, and it's the first one they give me is easy, the second one they give me is hard, and the third one they give me is the second one they give me is medium, the third one they give me is hard, right? That means that statistically, I'll pass 20% of interviews. You might say 20%, that's a failing number. So if they give you an easy, then a medium, then a hard, you're only going to get through 20% of your interviews? What if I told you that's sufficient, right? Because if I go do 10 interviews, look at that. Your boy's got the job. So it's really a numbers game, right? You could be an average engineer, do a lot of problems to put you in a position where you can't solve everything. You can only solve 30% of hards. But if you just play the numbers game, right, assuming that you get an easy, then a medium, then a hard, you might get 2 hards, right? And if I get 2 hards in a row, well, you're going to see that messes up this little statistical game here a lot. Oh, shoot. So now I got to do 20 interviews, right? But it's really just a numbers game. That's to say, be an average person, that's fine. Most of us are average. We didn't go to elite schools. We didn't, start doing math league competitions when we were 8 years old. That's not most of us, right? Most of us are normal. So, that's how statistics work, right? When it's a bell curve, right? Most of us are in the middle. So when you're in that situation, all you really need to do is do over 1,000 Leetcode problems, put yourself in a position where you've, pushed yourself, push, where you put yourself one standard deviation above where you were before, just that little variance, that little wiggle room you get by solving a lot of problems, and then just do a bunch of interviews. Right now, the problem is getting 10 interviews or 20 interviews, and then that's a different problem entirely. But if you're able to get that many interviews, eventually you'll get through. So it's just a numbers game, right? Even if you can only solve 30% of hards. Okay, so with that said, let's go ahead and pick a random problem and see if it can be done. Okay, so there's 65 pages on Leetcode. 1 to 65. Sorry, I was thinking about how I was going to do this earlier. So we're going to go to page 48. Page 48. Now, as you can see, I've already solved a lot of problems on Leetcode. So, of course, I don't solve the locked ones because I'm not paying. 2351 through 2400. Okay. 2351. Ooh. 2351. What was the other number? I already forgot. 2400. Okay. 2400. 2400. Problem 2351. 2351. Do-do-do-do-do. All right, well, I'm going to do another one besides this easy, but just to show you that I can solve 90, a large percentages of easies here. Okay, this for some reason that got out of this frame. First letter to appear twice. Given a string S consisting of lowercase letters, return the first letter to appear twice. A letter appears twice. So S, A, B, C, C. Okay, so this is very easy. So we have a scene array equals set. We look for all characters in S. Say if C is in scene, return C. Otherwise, scene add C. Is it possible that it has one repeated letter? Okay. So this will always return, even though it looks weird that there's no return statement here. Just trust me, it's fine. That was easy, but it's an easy, right? That should be anticipated. Okay. So what's the runtime and space complexity of this? All right, so time, we got big O of n, because it could be the case that it's the very last. So if we say that, so first let's say, if n is the length of S, right? It could be the case that everything's unique. Actually, no, this is constant because it's only lowercase letters. So there can only be, in the worst case, 26 in a row. After this, I've exhausted all the letters, so it can only be this. So this is O of 1 time, or O of 26, I guess. And same for space, right? Because I'm only adding to the space every single time I'm looking through this thing. This can only happen 26 times, so I can only add 26 letters in total. So that's space is O of 26 as well. I'm going to kind of just run through this because I don't want to spend too much time, talking about complexity. Is more about just solving problems. Okay, so let's go back and play this game again. So 1 to 65. Hopefully we'll do it again if we get a easy. We won't do the problem again. We'll just choose a different random number. So I'm a little bit hesitant here because I solve these. There's a lot of easies here. 2701, 2750, 2701, 2750, 2711. 2711 is a medium that I've tried already. I've attempted it and I failed it. I don't want to do that because I want to give us a problem that's completely new that I've never done before. Not that I've seen, because usually when I see a problem and I can't solve it, I'll attempt it, look at the solution and say, I'll go back to it later, right? And hopefully the idea makes sense to me. I don't like the idea of solving a problem right after looking at the solution because I don't really know if I actually understood it or I just copied the solution, right? So that's something to think about. 2101, 2150, 2101, 2101, 2150. Was that what it was? 2101. The first problem. All right, I've already solved that. 2147. It's a hard. All right, whatever. We're going to attempt it. Remember I said 30% of hards I can solve. So it's more likely I won't be able to solve this problem than I will be able to solve this problem. Super long description. I'm screwed. Okay, after a long library corridor, there's a line of seats and decorative plants. You're given a zero index string corridor of length n consisting of letters S and P, where S represents a seat and P represents a plant. One room divider has already been installed to the left of index 0 and another here. Okay, so there's at the edges. Additionally, room dividers can be installed for each position between index I minus 1 and I. At most, one divider can be installed. All right, so I can put a divider anywhere here. Divide the corridor into non-overlapping sections where each section has exactly 2 seats with any number of plants. 2 ways are different if there's a position with a room divider installed in the first way but not in the second way. Return the number of ways to divide the corridor. Okay, I might actually know how to do this. So what's going on here? What's going on here is, well, let's see what my constraints are. So I do have an idea, but it's hard when you're thinking through the idea. 2 seats. There's only one way here because each section has to have 2 seats. So I start from the left until I get 2 seats. All right, and I'm going to somehow place something there. And then I'm going to put 0 seats again. Call this the left, because I need to find a way to segment these sections until I get 2 seats. And then I stop. And if I'm in the last section and I go all the way over and I don't get 2 seats, I'm going to say that has to be included in the other section. So now I need to stop too before I get to this first seat. Because what's going on here is there's 3 ways here, because I can go here, here, or here. It doesn't change anything. So okay, so I kind of have a general idea. It's going to be some sort of multiplication between sections, right? Because like if you had seats like this, I wish there was a better example. There really isn't though. But if you had seats like this, right, like I could put the blue one here or here or here. And then if I had like another section like that, I could mix and match, right? So there's this mix and match multiplication thing going on here. So that's what I'm going to be doing at the end. I'm going to be returning the multiplication of things, right? But how do I find those segments cleanly? That's kind of what the problem is now, right? Because I'm trying to think about how am I going to find what these sections look like and split them up so that I know exactly how much I can split and where and when and all that. Okay, so because each section has to have 2 seats, right? All right, so I'm trying to think about a way to process this, guys. I'm sorry, I'm just thinking about it. Okay, so we need to somehow gather the sections, okay? We'll always keep track of the last chair. How about that? Maybe that'll help me here. All right, let me write down the problem. Plant, seat, seat. So I'll say my last chair was here at -1 initially. And then I'll count the number of chairs I've seen. So I've seen 1 chair, I've seen 2 chairs. Now that I've seen 2 chairs, I know that there has to be a split here or all the way up into the point that I see another chair, right? So say, okay, now my last chair is here in this position. And then as soon as I see another chair, I'm going to go, okay, that means there's wiggle room here, right? Between these 2 chairs, on the left, I'm good. I have a good point where it's already established. And then I can put it anywhere in these 3 slots. Right, so up until this point, I can put it into 3 slots. So this would be like, how many chairs have I seen? 2, 2, 2. This is one of those problems where I already know how to, like, I understand the general idea, but now it's thinking about how am I going to actually like write this code so it's clean, right? So I can get sections. So here I have 3 chairs. Oop, if I have greater than 2 chairs, I got to stop, make a new section. All right. Then I got to play the 1-2 game again. But it's possible that I never get 2 chairs again. Well, if that happens, then I'm screwed because I have to split it up into... Because these 2 chairs have to be together. Like, chairs are stuck together. There's no way I can get... Like, the first 2 chairs have to be with each other because this chair is married to this chair, right? So, there's... It's weird that I use that terminology. They're together. They have to be together. Those chairs have to be together. So, I know that as soon as I tease 2 chairs together, they got to be together. So, if I get to the end and there's not 2 chairs that are stuck together, then I return I return 0 there. So I can play that game there. Now it becomes a game of sections. All right, so I think I know what to do. So let's say last equals -1 to start. All right, the count, I'll call C the count of the chairs that I've seen. All right, and then I'll go through each, I guess, item in the corridor. I don't like the word item here. I'll just call it X. In the corridor. We're going to say the count plus equal if the current thing I'm looking at in the corridor, I do need the indices actually. So we'll just do this. Maybe we'll eliminate it. But just to get all the information from this array, right? I want the indices where things are at, and I also want the value of the thing that's there, right? So if X equals S, then it's a seat. I keep calling them chairs. So seat, and this is the difference. Okay. We're going to say, okay, if now C is greater than 2, well, we just found another chair that made it greater than 2. So we're going to say C equals 1. And then S, we're going to depend what kind of regions of space did we just create as a consequence of this. So our last chair was at 1. And then after the end of it, we'll say, well, if X equals S, then this is our position of the last chair. And then S append, we would say, oh, we'll do res equals 1, and then we'll just multiply it. So we'll say, we don't even need this S thing, I don't think. Not explaining what I'm doing very well here, guys. I apologize. Res times equal the distance in between the current thing times what? So the last chair was at 1. Our position is at 4. That gives us 3 slots. So that's I minus the last position of a chair that we saw. That'd be left adjacent. All right. If C not equal 2 at the end, we return 0. Otherwise, we return res. Please, Lord Jesus. Return res. Okay, why is it 4 here? So let's print C and res at each spot and L while we're at it. So here it says C is 1. That's what it initially starts as, so that's good. Res times equal, no, not L minus 1. Res times equal I minus L, my bad. All right. And per usual, I forgot to mod it. It's a very common thing that I do. Just forget to mod my answers. Oh, res equals res times this modded, just to get it modded at the end. All right. So that's a pretty easy hard, to be honest, right? Basically, the idea is you want to find the position that you're going to put these bars, right? And you want to figure that out somehow cleanly, and this isn't even that clean, to be honest with you. It could be definitely cleaner, and I'll work through it right now. But you want to find the positions of the bars, right? And then you do that for each section, and then it's just multiplying them together, right? So I can put one here, put one here. So I can do it. Now, the reason why this problem gets simpler is because these chairs always have to be together. So there's no way I have to put these chairs together, so I know kind of the spacing that there needs to be required. Okay, so what's the space and time complexity of this? So let's say n is the length of corridor. All right, space is constant, right? I just create this variable, and update it accordingly. And time is, yeah, this variable n. So we look at all n things, we update them accordingly, that's it. O of n. All right, we look at all n things, we do constant things. So we do n constant things, it's O of n. All right, guys, that's it for today. Let me know if you like this kind of style, right? I just wanted to show you what's possible after you solve a lot of problems, right? This is a 30% likelihood. I did an easy and a hard. So what was the likelihood that this was actually going to work out? This works out only 28% of the time, okay? So we got lucky today, right? It's a quarter of the time, makes sense, right? If I did this again, I probably wouldn't be able to do it, at least that quickly. All right, guys, peace out.